In this digitally driven world, the future of technology in education is helping teachers to expand beyond their text based learning and to engage students who learn best in other ways. Nowadays, modern technology is interactive, effective, and students learn by implementing, researching, and receiving appropriate feedback in the meantime. In honor of Sir C.V. Raman, Vishwa Bharati Public School, Noida celebrates National Science Day on February 28, 2021. The theme of the year is Future of Science, Technology and Innovation, Impact on Education, Skill and Work. India celebrates National Science Day on 28 February every year in honor of physicist C.V. Raman. Discovery of Raman Effect, which gave Asia its first Nobel Prize in the science in 1930. In 1954, India honored him with its highest civilian award, the Bharat Ratna. Have you ever wondered why is the sea blue? This is because of Raman effect, which was discovered by C.V. Raman in 1928. In 1921, Raman was on a trip to Europe, and during his return trip from London to Bombay, Raman's mind became fascinated with the deep blue color of the sea and some icebergs. Unable to accept Lord Ranelagh's explanation that the color of the sea was just a reflection of the color of sky, he was eager to know the exact reason behind the phenomenon. He, along with his team members, conducted a series of experiments with transparent block of ice and light from a mercury arc lamp. In 1928, Raman was able to show that the blue color of the sea and the ice were the result of the scattering of sunlight by water molecules, which is known as Raman effect. Understanding Raman effect. When a sample is exposed to monochromatic light in visible region, sample absorbs light and major portion of the light get transmitted through the sample. However, a minute part of the light is scattered by the sample in all directions. If the scattered light has the frequency same as the incident light, then the scattering is called as Rayleigh scattering. However, it has been observed that about 1% of total scattered intensity occur at different frequencies from the incident frequency. This is called as Raman scattering. Raman scattering can be explained by photon-electron interaction. The electrons at different vibrational levels, they are defined by specific energy differences. When an incident monochromatic light interacts with the electron in the sample, the electron absorbs energy from the incident photon and rises to a virtual state of energy. The energy transferred is given by the formula E equal to h nu, where nu is the frequency of the incident photon. The electron then falls back to energy level by losing energy. Sometimes electrons, when losing energy from the virtual state, can fall back to the different vibration levels. In this case, the energy lost by the electron is different than the energy absorbed from the incident photon. As a result, the photon emitted by the electron has energy different than the incident photon. This is possible when the frequency of the emitted photon is different than the incident photon. This gives rise to Raman scattering. Depending upon the final energy of the electron or final vibration level of the electron, Raman scattering can be separated into Stokes lines and anti-Stokes lines. If the frequency of the scattered photon is less than the frequency of the incident photon, Stokes lines are observed on Raman spectrum. This happens when the electron absorbs energy. Similarly, when frequency of the emitted photon is greater than incident photon, anti-Stokes lines are observed. This means that energy released by the electron. The Raman spectra gives the molecular fingerprint and it is different for different molecules. By studying the spectra, one can identify the rotational level and thus a particular molecule. This helps in performing qualitative analysis. Similarly, the intensity value of particular Raman lines helps to determine the concentration of a molecule in a sample. In this manner, quantitative analysis can be done. Thus, Raman spectroscopy can be used to perform both quantitative and qualitative analysis on a sample. Hand-handled Raman scanner. It is robust and reliable portable spectrometer which enables rapid identification of explosive, narcotics, toxic industrial chemical warfare agents and other illegal materials captured at a crime scene without breaking the evidence seal on the plastic bag or opaque containers. Thank you for watching and happy National Science Day.